All right. Okay, resource allocation. Yeah, graph array scheme for deadlock avoidance. Single instances of a resource type. Each process must priori claim maximum resource use. Use variant of the resource allocation graph with claim edges. Okay, this is a claim edges symbol, yeah, which is process P towards RJ. So this indicate that process PJ may request resource RJ. The PJ, right? This one is PJ, yeah, PJ. And then may request resource RJ represented by a dash line. All right. Okay. So it's the dash line. This arrow should be dash. Yeah. So claim age, yeah, converts to request age, yeah, when a process requests a resource. So that request age converted to an assignment age when the resource is allocated to the process. When a process is released by a process, assignment age reconvert to a claim age. All right. So resources may be claimed a priori in the system. Okay. A cycle in a graph imply that the system is in unsafe state. All right. Yeah. So P1, okay, resource, continue on this, yeah, same issue. So P1 is holding resources R1. P1, yeah, is holding a resource R1, okay, and has a claim on R2, has a claim on R2, okay, this with the dotted, yeah, dotted line or dash line. So, and also P2 is requesting R1. P2 is requesting R1, yeah, and P2 has a claim on R2, and P2 also has a claim on R2. So here means no cycle. So system is in a safe state. Yeah. Okay. So this is we call this the process, the step, the scenario, and this is the diagram, state diagram, or here we call this resource allocation graph with claim edges. All right. Okay. So the graph, yeah, next, based on this diagram, yeah. Okay, the graph over slide before with a claim age from P2 and P1. Okay, P1 and P2, P1 to, sorry, P1 to R2, P1 to R2, P1, sorry, P2 to R2, P2 to R2, yeah, okay. So it's changing here, this, yeah, it's changing to an assignment age. All right, so there is a cycle in the graph, okay, shows, yes, shows that unsafe state. Okay, so is there a deadlock? Okay, so I think you know what's the answer, right? Okay. With this cycle, after they change this. Yeah. Okay. The example of the resource graph allocation. Right. So next, suppose that process PI or PJ or PI requests a resource to a resource RJ. The request can be granted only if it converting the request age to an assignment age, okay, does not result in the formation of a cycle in the resource allocation graph. Otherwise, the process must wait. Okay, all right. So, Banker's algorithm. Yeah. So, multiple instances of a resource type. Okay. Each process must a priori claim maximum size. When a process requests a resource, yeah, it may have to wait. When a process gets all its resources, it must return them in a finite amount of time. So this algorithm, yeah, could be used in a banking system to ensure the bank never allocates its available cash in such a way that it could no longer satisfy its customer. Yeah. Example one, bank loan. Yeah. Bank with fixed amount of capital which operate as follows. First, no customer will be loan exceeding the bank's total capital. Next, all customers will be given maximum credit limit when opening an account. The sum of all loan must not exceed the bank total capital. And then the bank total, all right, if you look here, okay. The bank total capital fund is 100,000, yeah, ringgit here, and has a 3 customers, such as C1, C2, and C3, each with credit limits, okay, 40,000, 50,000, and 80,000 respective. Yeah. Okay. Yeah, the diagram. So if you look here, this is a total capital fund. This is total loan and available, and this is remaining. Okay. Remaining credits. Okay, for each of the customers. Okay, all right. And then a safe state means the bank has enough money enough money left to satisfy customer needs. Okay, so this is means by the safe state. Yeah, so enough money left to satisfy customer needs, which is remaining credit. Yeah, all right. So C1, example 1B, yeah. C1 and C2 made a loan of 20,000 and 10,000, yeah. So customer 1, customers 2. And then if you can see this, customer 1 make 20,000 and customer 2, 10,000. So this is the remaining. Yeah. All right. So that, and then check this. Yeah. The available fund. Okay. Left 10,000. Okay. Unsafe state, the bank does not have enough money left to satisfy customer needs, which is available fund less than minimum remaining credit. All right. So second scenario. Okay, bank algorithm, which is data structure of the bank's algorithm. So this one regarding algorithm. All right. So how we develop that kind of things. Okay, this is the step-by-step pseudocode, or we call this data structure. Yeah. So let n is a variable, equal the number of process, and m equal the number of resource type. Yeah. And then available length. Length of the m is available is length or a vector of the length m. And under another variable, max mean is n times m matrix. Okay, for the available variable, if available, okay, j equal k, yeah, the number, because this is a vector of length m, then there are k instances of resources type of Rj available. For the n times m matrix mean if a max, yeah, I and j equal k, yeah, equal k, okay, then process pi may request at most k instances of resource type Rj. Yeah. All right. The next allocations. N times M matrix. Yeah. If allocation I, J, K equal K. Okay. K is number of resources. Yeah. Or the K are instances of resources type. Yeah. Of Rj available. Okay. That's by K. Then Pi is currently allocated K instances of Rj. And then needs n times m matrix. If needs, yeah, equal k, then pi or pj may need at most k more instances of rj to complete its task. Okay, so that's reflect of the current scenario. Yeah, recently, previous one, like this. Yeah. Okay, need. So equal maximum minus allocation. Okay, that's how they're representing that. Okay, using a matrix. All right. So regarding a safety algorithm. Yeah. So what first, let works and finish be vector of length m and also n respectively. So initial or initialize work equal to available, finish equal to false, for I1 until n minus 1. Okay, all right. So next, find an I such that both, which is finish I equal false and needs I less than work. Yeah. If no I exist, if no such I exist, go to the step 4. Yeah. Here. And next, the third step, work assign. Yeah. Then work plus allocation I. yeah, and then finish I equal true and go to the next. Sorry, go to the step 2. Yeah, correct. Repeat again, yeah. And then if finish, okay, I equal true for all I, then the system is in unsafe state. Otherwise, it is an another state, which is unsafe state. All right. So, example of safety algorithm now. So we got 5 processes. Start with P0, and the last one is P4. Yeah, 0, 1, 2, 3, 4. Okay, 3 resource type. We have the A for 10 instances, B with 5 instances, C with 7 instances. Okay, how many resources? 3, A, B, and C. So this is snapshot at time T0. Okay, T0, yeah, T0. So allocation time, we have this at T0 at the beginning. Okay, this is the allocation for each of the P. Okay, P0 is 0, 1, and this, and P2, P1, P2, P3, and also P4. Yeah, and this is the availability. This is a maximum. Yeah. Okay, we have the available. So available needs and the maximum, how much they can go. Yeah. And then this is similar that the table. Okay, they try to representing this scenario. Yeah. This example 1B trying to representing through the algorithm. So this is the at the time 0. Yeah. So available is total resource minus total allocation minus total allocation resources. Oh, so in order to get the availability, yeah, here A, B, C. Okay, total resource A, B, C. We have the 10, 5, and G. Total resource. Okay, total resource for A, okay, is a 10. Total B is a 5. And total C is a 7. Okay, so look to where? Look to where? Look to instances in here. 10, 5, and 7. Yeah, here we have 10, 5, and 7. And then for the total allocation resources, here 7, 2, and also 5. Total allocation. Okay, so total allocation. Yeah, okay. Okay, so where the value comes for the total allocation resource? Yeah, total allocation resources. Yeah. So here there is a 725. So if you look here, all right, in here total allocation, this is allocation, right? So total allocation means you have to find a sum of resource A, resource B, and resource C. Then you will get 725. Yeah, and then minus that, so you will get this value. Okay, all right. Okay, so the total of this, so 2, 3, 2, 7 is a 7. and then 1 and 1 for the B, so got 2, and then 2, 1, 2 is 5, so we got 5, and we subtract or minus, so you will have 3, 3, 2 for each of the resource. Right, so that's availability of the resource. Yeah, availability of the instances. I can say that. Yeah, all right. Okay. Okay, next, the content of the metric needs is defined to be maximum to allocation. So looking for the needs is defined to be maximum minus allocations. Okay. So this is allocation. These are needs for each of the resource. Yeah. From each of the process. Yeah. PO, they need 7, and so on. Yeah. P1, P2. Okay. 0 for P3 and also P4, 4, and then this and so on. Yeah. Okay. So in order to get a need maximum, need to minus the allocation. Yeah. All right. And next, so first we need to, this is initial, yeah, state, and then we need to calculate the need for each process. Okay, this you will need the process. Okay, after we define, we need to define this, what's the need, and then find out this, and then you will get the needs. Okay, try. Okay, try to find out that. Okay, so this is the one. And next, so step 1 works, okay, equal available, yeah, which is 3, 3, 2. Step 1. Okay, available now is 3, 3, 2, yeah, for each of the resource, yeah. And then step 2 needs for the P0 must less than the work cost. So P0. Okay. First, less or equal of the work. Okay, P0 needs. So step 2, P1s, check. They need to check because this is a matrix, so you need to check each of the process. Next is a P1, yeah, and then check the availability. Okay, the val. So for the P2, and also now if you look here, okay, all right. So needs P1. Where is need one? This. Yeah. So the current available, which is for each for the work, is 332. Okay, here. The look. 332. Yeah, 332. Available 332. Okay. Yeah, yeah. So it's less than. Okay, 332. Okay, and then it start work plus allocation because it fulfill all. Yeah, fulfill all the metrics. Okay, so it start. The first one, if you look, P0, the needs 743. Yeah, look to 332. This is the current availability value. So it match this true. Okay, so now the step increase. Yeah, so step 3. Okay, so allocate this. So this is a statement to assign, yeah, the value. So I try to allocate because possible, yeah, based on this. All right. And then so 332 plus the allocation. What is the allocation right now? 220. So 220 here for the P1. So, and then next, when they plus, so to get this value, 32, this is a current value, okay, for the work. Okay, all right. And then done that, and then go to the step 2, another metric, which is for P2, check. The same thing. Okay, they are repeating. And then step 3. So check this needs, so doesn't, I mean, is doesn't match. Okay, so go to the step 3. Yeah, because it's 6. Yeah. All right, and then step 3, just go to step 3 for the P3. Yeah, P1 have done on P1. Sorry, P2, and then go to P3. Okay, P3, and then so 0, 1, 1 needs for the P3. Yeah, next is a P3 of yeah. Okay, go for this and check. Then current is this less than. So what happened? Allocate, and then now is the allocation. Okay, is 211. So next, this value changed to 743. All right, and next repeat all other process is for the 4 and so on. Okay, all right. So now the system is in a safe state scene. The sequence of P1, P3, P4, P2, and P0 satisfy safety criteria. All right. Okay. So step 2. So another to proceed. Step 2. Needs 4. They continue. Okay. The new step 4. Here we look this. And then 431. This is step 4 needs. And then the current, check the current available or works value, and then is it less than equal, is it true or false? So there's a true, yeah, and then allocate. To allocate P4, so P4 currently is 002 for this, and then here 002. So work got the increase value now 745. Yeah, all right. And then step 2 again for needs for P2 less than works. P2, so P2 here is a P2. Check less than works is a 6. Yeah, P2. Okay, this one. And then less than 745. Is it true or false? Yes. If yes, so allocate that, and then you can see the current allocation is 302. So we change the value now. So work, we got 1047. Yeah. And then go to step 2, which is for P0 again. Okay, P0. And then check the work current value. Now 74747, what you call it? 743. And then check, is it true or not? True or false? The answer is yes. So allocate. Then work, we got a new value. Yeah. Okay, 1057. And then next you can see the sequence of the process based on their needs, allocation, and so on. Okay. So what is the safe sequence? What is the safe sequence produced? Okay. So now they satisfy all. Okay, until all process, satisfy or allocate. Yeah. Okay. So resource request algorithm. Let our request RJ be the request vector for process PJ or PI. PJ, right? PJ. Then request, then we have equal K, process PI wants K instances of resource type RJ. So if RJ, yeah, K request check less or equal needs, go to step 2. Otherwise, raise error condition since process has exceeded its maximum claim. And next, if request less than or equal available, go to step 3. Otherwise, PJ or PI? PI, I think, because the I equal, so each of them. Yeah, PI actually. Here is a PI. So it doesn't matter because it's representing the number of the process. Okay, that's the main thing. So we need to go each of the process. Otherwise, PI must wait. Yeah, since resources are not available. All right. And then next, pretending to allocate requested resources to PI by modifying the state as follows. So here we should pretend to allocate requested resources. Yeah. So available equal available minus request. And then allocation means allocation plus request. And then needs minus request. If safe, the resource are allocated to PI. If unsafe, is PI must wait and the old resource allocation state is restored. Okay, so that's for to avoid this scenario. Yeah, all right. So example of resource request algorithm. We got the 5 process P0 and P, yeah, P4 here. All right. Okay, so 3 resource type. Okay, and then we want to double check the same. This one for request resource algorithm, yeah. So we have a resource A with 10 instances, B 5 instances, 7 with 7. Sorry, C with 7 instances. Okay, this one at T0. Yeah. So this allocation for each of the resources, and also this one P0 and so on until P4. And this one maximum, this one for available. All right. Okay. And then so determine the safe state, and then we already know how to calculate this from the previous slide. Okay, and then next, so same thing, step 1 works, okay, equal available 332. Okay, 332. This is the first step. And then next, check, okay, P0 equal or less than work. The work is now 332. And then where is the for the P0. P0 is 743 right now. Yeah. And then doesn't, so the answer is a false. So we go to the next P, which is P1. So it has 112, 122, yeah, and then check if it is less than or equal to work. Then what's the answer? This one. So the answer is yes, and then go to the step 3, then allocate to the P1. So we change the value after allocate, then 532, yeah, and then next the needs. Now the needs, check P2, is it less than the work? Okay, 532. So the work, the needs, what is the current need for P2? Okay, P1 is done. Go to the needs. Okay, P2, we check P2 right now. Here, P2. Okay, I think it's a 6 right now. And then where's the work? So this is the current work value. Check true or false. Not false. Go to the next for the P3. So here P3, and then checks the needs with the work 011. Okay, 011. This is the current for the work. And then is it less than or equal? So is yes. So this value, yes. If yes, we allocate, and then when we start allocate, so we increase the value, yeah, and then so this is the current value of work, okay, and then repeat all other process also similar that we did before, yeah, and then next step 2 at P2, P4 needs. Where is P4 need? Here, 432. Yeah, and then goes to, and then check if yes. So this is current value of work, and then we check is it true or not. So if true, they will allocate. After allocate, we got the current. Yeah, allocate. So this is the current allocation for the P4, and then we assign that, then work got the new value. Then next, go to step 2, which is for P2. Check for the work. Where's the current work? Okay, current work is the 745. P2, we have one here for P2. So here's 6. P2 is a 6 right now, 600. So is it true? Answer is yes, and then we allocate that. And then 745. Then we allocate with 302 for the P2 right now. Yeah. And then it became 1047 current value. And then it goes to P0 now. Here, check the 743. And then check with the work value, which is 1047. Is it true, less than or equal? So the answer is yes. And then start allocate to the P0, and then work we got there. After assign the work change to the new value 1057. Yeah. Okay, and then what is the safe sequencer produce? So the system is in the safe state since the sequence P1, and next P3, P4, P2, and finally P0 satisfies, yeah, safety criteria. And so this is a get use of the safety algorithm. All right. So goes to the next one. Yeah. So we have the example P1 request 102. Yeah. 102. 102 right now. So check the request was less than available. That is 102 less than 332, which is must true. Yeah. So the available right now. Okay. And then since a request one less than or equal needs, and then n, okay, request one must less than available. Next, pretend this request has been fulfilled by execute resource request algorithm. Yeah. Okay. P1 request one. Where is the P1? P1 request 102. Yeah. P1 this. Yeah. P1. So we want to see that. So 332 right now. So that's a true. Yeah. Okay. P1 is here. Is a 2. P1 is a P1. And P1 here, right? Okay. The request P1 request 102. Okay. 102. That is 102. Example. Okay. So less than 32 is a true. Currently is 102, but they require 102. So currently is a true because this algorithm 332. And then since request less than needs, so n request less than available, pretend this request has been fulfilled. And then execute resource request algorithm. Okay. All right. All right. Okay, I need to clarify this. Yeah. So here, if you look properly, so this is the request must less than available. This is request 102 request, the new and new variable must less than 332. 32 is available. Okay, available value. Okay, and then this must true. Okay, since request the current variable which is request is 102 less than needs. What's the value of needs? Needs is here 122 for the P1. Yeah, and they need n. Okay, not or but n. And request must less than available. So the request is 102 and also give a true value also. So the current available is 332. This. Yeah. And then next is pretend this request has been fulfilled. Then now next is execute resource request algorithm. All right. So available. Okay. So just repeating this. Available must minus the 332 requests, and then so this the current availability, and now allocate that allocation for the P1 is allocation P1 is to 0 plus the request. Okay, the request 102, so now 302. Yeah, allocation. And then the needs, which is needs P1, and then minus request. Okay, so this is a current needs, new current needs, okay, which is 0 to 0. Yeah, all right. Yeah. Okay, they will check again. Yeah, so current needs. Yeah. Okay, so current needs. Okay, and after that, so step 2, work equal available 230 right now. Okay, we continue. And then go to P1 again. So check the with the work variable now. Okay, like work, the work. Okay, the values were 2, 3, and then check with the needs. P1 is 0 to 0 now. Okay, with the, is it true or false? So the answer is true. So start allocate. So 230 with 230 is the work, and allocation is 302 now. And then so it become the new value for the work 532, and then goes to step 3 now. Repeat again. This P3 must check the work parameter. Okay, work, and then which is we have 011 for the need for P3 for 3, yeah, here, here, and then check the work value, compare, is it true? So yes, and then start allocate, and then they got the new value for the work. Okay, and then same again now, right? So we check step 2 P4. We are in P4 now again. Check with the compare or check with the work value. Okay, is it less than or equal? So now the answer is true. So start allocate this work, then plus the current, which is the location is here. Yeah, for the P4, and then plus the work, and then got the new value 745, and then we have a needs P0 less than a work. Yeah. Okay, check P0 again. Is it true or not? Then the answer is yes, and then start allocate 745, and then got the new value for the work now. And then step P2. Okay, P2302. Yeah, check now for the P2 here. Check the value P2, and then check the current value of compare, and then check whether true or not. And the answer is yes, and start allocate. So now work got the new value 1057. And what is the new safe sequence? So this is the new safe sequence P1, P3, P4, P0, and finally P2. So satisfy safety requirement. So the system can grant the request of process P1. So this is the sequence. Yeah, P1, P3, P4. Yeah, P1, P3, P4, and P2. This is a sequence. So the system can grant the request of process P1 and so on. Yeah? All right.